I'd now like to talk about DNS, the domain name system. Here are some things that you'll want to know for an exam in my course as it relates to the material I'm about to cover. So you don't necessarily need to know everything, but these are the things that you absolutely positively have to walk away with. Here are some of the terms that would be important to be familiar with: host names, DNS, and DNS zones. All right, so let me start off by talking about a problem that could exist. Imagine that in the internet that you could only communicate via IP addresses. Technically, that is how our computers communicate one to another. What if we didn't have friendly names associated with websites like google.com, etc.? Then, as you look at this picture here, you would have to if you could only work with IP addresses, you would have to enter this in for everything. How would this impact you in your life if every website you ever needed to visit only could be visited via its IP address that you had to retain and maintain? Well, you probably have, I don't know, maybe a wallet with your favorite IP addresses listed in it, or as one person suggested recently, maybe they would memorize Google's IP address and then not worry about anything else after that. I suppose that's true. Okay, so one of the things that we can do to make it so that we don't have to memorize IP addresses or other types of addresses to identify a particular host or computer is to have something called a host name, which is a friendly human readable name for a computer. And we can think about host names in two different contexts. One is on a little local area network. We might have a computer that we rename it to be Windows 10A or Dave's computer or something like that. And another way we might name a computer is to give it a fully qualified domain name like www.toolegit2quit. Either of those are examples of host names. All right, now in terms of resolving a host name, meaning finding the IP address associated with it, typically we can use a command like ping to have our computer do that for us. But there are three steps that we need to understand for actually that our computer uses to resolve or find out what is the IP address associated with it. So it has a hierarchy of steps that it goes through, and if it finds what it needs, it will stop. So the first thing it will do is it'll check, is it me? It will check its own host name to see, is it the thing that has the particular host name that you're looking for, and then return the IP address associated with it. So let me come over here and type in a command on my Mac, and I type in host name, and it responds with, this is my host name. And so if I copy that and I ping it, okay, now I have an IP address associated, so this is the IP address that I have at this particular moment. This is associated with that. So if I was telling my computer to ping something, the first thing it does is it checks, is that me? And if the answer is yes, then it doesn't go forward. If that human readable name isn't me, then the next thing it's going to do is it's going to check its host file. And then third thing it's going to do, and that's a local file, we'll see that in just a second. The third thing it's going to do is it's going to check its local DNS database. Or sorry, I said that incorrectly. The third thing it's going to do is it's going to check the worldwide distributed database of DNS. All right, so I asked this question this way: Lord, is it me? So I already gave that demonstration to you regarding your own personal host name. If you don't find it there, we look on our hosts file. So let me give an example of this. Well, first let me explain that this file exists either on your Windows file at this location or on a lot of Unix-based systems, it exists at this location. So what you could do is you can open up something like, my words are escaping me for a second here. Anyway, what you can do is you can open up your etc host file on any Unix-based machine like my Mac, and we can change what a user-friendly name resolves to in terms of an IP address. So I'm going to use this command. Well, okay, so let me walk through some things here. First, I'm going to get an IP address. So I can ping www.slcc.edu, and I get back this particular IP address, which was 144.35.15.16. Okay. Actually, I just wanted the IP address, and we're going to use this IP address in a different context so it's not associated with that domain name. What do I mean by that? Well, so let's say I'll type in sudo vi etc hosts. I'm going to open up a file, and now that I'm in this file, I can modify it. Let me pull this down a little bit, and I can plug in an IP address and associate it with a domain name. So I just typed in that IP address with this particular university in our state, and now whenever I use this friendly name on my computer, it's going to be associated with this IP address. So if I close that now and I say ping www.utah.edu, I get this address being returned to me. So now if I were to type into a web browser www.utah.edu, it's going to check my host file for the IP address associated with this domain name, and it's going to come up with Salt Lake Community College, which would bother people if they were going to University of Utah and this is the website that came up. I think it would be a real fun joke to go onto people's local computers and change their host files so that actually happened. Okay, so just a note, before we had our DNS system like we do now with our distributed database, these host files could be distributed and shared across computers, but in order for people to have friendly names to use when browsing the internet, but this became a bottleneck, and so we needed a distributed database to make all of this work better. So we have the DNS system, and the DNS system relies on individual DNS servers, which are really distributed databases that contain a portion of the database related to domain names and IP addresses associated with them. So in the big picture, let me just step through these items. A name server is something that maintains a list of host names, so friendly names, and IP addresses associated with them. So they're waiting for somebody to contact them so they can return that information. It's good to know that each server only maintains a small portion of the overall DNS namespace in the world. So we don't go to one centralized authority for DNS names, for host names and IP addresses. We go through a hierarchical progression to find the right zone that contains that information, and we'll find that in a minute. For any given DNS server that we go to make a request, that server can either give us a response to that question of which domain name goes with an IP address, or it can forward it to another server, forward us potentially to another server. So here's an example of where we put in our DNS server. So this is where we go to query and find out it's where our starting point is, at least from our host computers, but it's a little bit more complicated than this. Usually there's a traversal of the distributed database in order to find out and return to our computer through this IP address what is the actual IP address of a site we want to go to. So let's go through the process now of domain name resolution. So if we have a client here, which could also be called a resolver, we might want to go to a website called www.byu.edu. Now, our computers only communicate by IP address, not by human readable names, so it needs to know the IP address associated with that. And what it's going to do is it's going to receive the results of queries to 3 different databases to eventually return an IP address that is the IP address of www.byu.edu. So the way this goes is a client, a web browser, a computer has a resolver built into it, and it sends out a request to, for example, you're an internet service provider. And the internet service provider, the first step it does is it looks at the address that you sent, and it reads it from right to left. And reading it from right to left, it says, okay, I need to find something that's within the edu database of domain names. And so what it does is it first goes out to what are called the root servers. They're kind of invisible. And there's an implied dot at the end of a domain name, which means there's another database or area that we're looking in, but we don't talk about it ever. So maybe this is our crazy aunt up in the up in the attic or something. No offense to ants, by the way. But anyway, we just don't usually talk about it, but it's there. So our internet service provider says, hey, what it's going to ask is, hey, you name server, can you tell me the name of servers that know about edu, that have edu entries associated with them? And it says, yes, I know the IP addresses of edu name servers or edu databases. So it says, great. It gets one of those addresses and it says, okay, edu database, you know about things that have something before the name edu. Can you tell me who has a database of information about byu.edu? So this is considered a top-level domain. So that this top-level domain, edu name server, says, yes, I know where to find the byu.edu name server. It's at a particular IP address. And so there'd be others as well, utahstate.edu, etc. It would know many of those, but we're just asking about byu.edu's name server or database lookup. It says, I know where that database is, and it returns you that IP address. And so you said, okay, byu.edu name server. Can you tell me what is the IP address for www.byu.edu? And this name server is authoritative for the domain byu.edu, that portion of the internet. And so it returns back that IP address, and it comes back to here. And if I had another picture on here, it would be of the actual computer. So the www.byu.edu is actually going to be on a different IP address than the name server is. And it's possible to further create subdomains and further name servers and have this iterative process go further. So we could go, for example, learning.byu.edu or testing.learning.byu.edu. And what we could do is create more and more name servers that go further and further down the line until finally a name server responds with the address of the server that you're supposed to be going to. Now, within any of our name servers, we have a list of different types of addresses that we're going to see. I'm just going to highlight a few of them here. The A records are similar to what we saw in our hosts file, which is it's a listing of a friendly name and an IP address that's associated with it. Sometimes we have CNAME records as well, and a CNAME record is really just an alias to another friendly name, and another friendly name is going to be represented by an A record, which has an IP address. So hopefully that makes sense. It's kind of an indirect way of getting to this stuff. So like we could say, for example, www for a particular domain is associated with a particular address with an A record. But then we could also say that RDP is equivalent to www using a CNAME record, and then so you just keep on digging until you eventually get back to the www is associated with a particular address. So you can kind of create aliases to an A record using CNAMEs. Mail exchange records. This gives us the address related to mail delivery, which is important. We can also return the address of name servers, so an NS name server record. This gives us the address of other name servers, which might be authoritative in answering questions we have. Perhaps there's a subdomain like learning.byu or testing.learning.byu.edu. We could create entries related to those databases, whereas such that they are going to be the authority for those addresses associated with that and not the particular name server that you're currently at. Now this is a little bit too small to see, I suppose, but if you open up a DNS manager in Windows Server, for example, over on the left-hand side, you'll see a domain that you're authoritative for, meaning I am in control of isislab.com or whatever domain name that you register. And then over here, here are the records that you've created. So you see that here are they're in the second column. These are all A records that have been created. Here is kind of the prefix on the domain, so you could add intex11.isislab.com as a domain name, and it's going to be associated with this IP address. So that's how that material looks. Okay, another thing that is very, very useful in this context is a tool called NSLookup, which is available on most machines. NSLookup can help us find out where an IP address is hosted or what its IP address is. So for example, if I wanted to know what the domain name is associated with daveandkettles.com, I can type it in like that, and it indicates to me that I'm going through this particular DNS server. I didn't request it to do so, but it's going through this particular DNS server in order to resolve this question. And the answer that I got back is that at the end of the day, this domain name is found at this IP address. Now, as part of this NSLOOKUP command, in addition to the fully qualified domain name, I can also put in the domain name server IP address after it. So in many screens you've seen me use Google's, which I believe is 8888. So rather than maybe using my local one, which is 10.8.0.2, I could use others out there to determine and understand what is it that they see. I've mentioned this term resolver before, but let me just repeat it one time. That resolver is the software that is used to resolve a name, a host name, to an IP address. So that could be some software that's running on your local computer on behalf of your browser, or it could be something at your internet service provider. Any of those could operate as a resolver. Okay, as you register domain names and start to do development experiment, you'll find that sometimes things aren't working or it can be flaky. And one of the things you want to know is you want to know for certain, how is my domain name propagated throughout the internet? And so I don't have a little picture for this at this moment, but it probably would have been useful. Imagine that your website is at a particular IP address somewhere on the internet. How do you get there? Well, you need to have a name server that's authoritative for that domain name. And not just one. Domain registrars require that you have 2 domain name servers or databases that are out there that are authoritative for determining what is the IP address associated with your domain name. Now, in order for people browsing the internet to find your website, they need to get to your name servers. Well, how do they do that? Well, your name server needs to be registered with a top-level domain name server like .com or .net or .edu. And furthermore, those ones need to be associated with a root server, but you don't have to worry about that part. Now, we want to know if this is all working and hooked up correctly or not. So let me go to this particular website right here, just dns.squish.net, and I'm going to open up a local news site that says www.ksl.com. And I want to say, I want to see how this is resolved. I want to know the A record associated with this website. And I can get information from name servers, technically all the name servers that are associated with determining what the IP address is for that domain name. Now, here is the ultimate domain name. It says ksl.com is in the address this right here. Okay, there's our summary. How do we know that? Well, here are 4 different name servers, and each of them and these name servers have IP addresses associated with them. So if your computer or your ISP were doing DNS resolving, they could go to any of these on behalf of ksl.com, and the database in there will have an A record that says ksl.com is associated with this IP address. Now, furthermore, we know that there's a traversal that happens before we even get to those name servers, and so here's a little bit more complicated way of viewing things. We know that the root servers are at the top of everything. So across the internet, there are going to be several root servers, and this little tree is here. And in our root servers, a root server is going to know about top-level domain name servers, and it's going to have the IP addresses for each of those. And in each of those, for something like a .com, we can check its database for all of the ones that are being used for .com responses. All of those are saying, if you want to know about ksl.com and its name server, you can go to ns1.ksl.com, ns2, etc. These are the 4 different name servers that will have information about what the ultimate IP address is for KSL.com. So this is the traversal that it goes through to find 4 different databases that will know the answer to your question, which is what is KSL's address ultimately. Okay, last thing I might mention here is just talking about registering domains. Typically, in the beginning, you might have gone to a website like Network Solutions, but now there are lots of different places you can go to register a domain name, like GoDaddy, for example, is common. And when you register a domain name, you become the authority, or you have the opportunity to become the authority for that domain name, meaning you can create lots of subdomains under there. And registrars require that you, as part of becoming the authority for a domain name, that you have at least 2 name servers associated with the highest level domain that you have that you just registered. So if you registered Too Legit to Quit, technically there can be www.toologittoquit and learning.toologittoquit and rdp.toologittoquit. As the authority, you are in charge of Too Legit to Quit, and you need to tell it what the name servers are for that, for starters, and then you can do as many subdomains and other sub name servers as you want. So just be aware that you have to know about those 2 name servers. So, all right. There's one other thing I know I need to remember. Just one second here, in terms of registering that. So just hang on. I can't remember right now. Well, okay, since I can't remember what the last thought is, I guess I'll just end there. But now that you've seen all of this information, you should be able to answer these questions. Thank you, and have